So as we said, the electron dot notation for this particular element that we are talking about, carbon, only shows the dot notations for the valence shell that contains 4 electrons. So going forward, this is a way in which most of the elements will appear when we are trying to give a demonstration for the reaction of these particular elements. So in that case, we talked about the sodium and the chlorine, which are reacting. So the electronic dot notation for that particular kind of a reaction will be represented as such. So sodium, its valence shell consists of a single electron. So, and for a quick reminder, this particular dot notation can be given in form of a cross, in form of a circle, or in form of a dot. So either of these particular 3 representation can give an electronic dot representation for this particular element. So we give a valence electron, which is 1. Outermost shell or the valence shell consists of 1 electron. So that's the representation. And for chlorine, it consists of 7. So we shall give it 7 electrons. So in that case, we can observe that, as we talked about the octet rule, chlorine requires 1 electron in order to attain the octet rule. And for sodium, it will lose this 1 electron for it to acquire the octet rule. Although for that case, we are going to learn about ions and see that they are not much more stronger than elements which have been bonded to complete. So for that case, that particular electron will move to chlorine in order to enable it to attain the octet rule. So for that case, we shall have sodium with a positive charge after losing an electron, and chlorine with an octet state, whereby this one will be this particular electron that has moved from sodium to chlorine. So for that case, that's a way in which we are going to represent the reaction between compounds. Now for that case, for elements which are involved in bonding, they'll be sharing valence electrons. In this case, to form covalent bonds for organic compounds. And for that case, for ionic compounds like sodium chloride, they'll be forming what we call ionic bonds. So in that case, I think that one gives us a basis for organic chemistry. And some of the concepts that we have learned here, we're going to see how they are going to be applicable as we go forward. Now, one of the objectives of studying, of course, as we said, chemistry, is to know the applicable laws and the nature of the chemical reaction. So which means in some reactions that we're going to learn, there will be some standing rules which will have to be observed. So for that case, we shall just go into our topic after learning about that long introduction, of course, that entails some of the basic concepts that we need to know. So let's go into our main topic. So the organic chemistry, so the term we have talked about the aspects of chemistry and all the basic information that we require for this. So in that case, we shall come to organic. So the term organic is familiar to us because in our day-to-day activities and maybe our endeavors, we have come across terms like organic fertilizer and some other terms like organic food, and some of the terms that are even similar to this, that for instance, organism. Now, it's upon us to ask ourselves, what does the term really organic stand for? So the term organic actually refers to something that is derived from living organisms. So the term organic refers to something that is derived from living organisms. So now, originally the term organic was the study of compounds extracted from living organisms and their natural product, as we have said. So for that case, we shall see on how it evolved over time and came to the concept of organic chemistry. So if it was the study of living organisms, then basically it was believed that the organic compounds that were present at that time, definitely they must have been derived from living organisms. So that led to the concept of organic chemistry, of course, which we shall see that there was a mainstream belief that these compounds which were derived from living organisms, there wasn't another alternative of trying to come up with those particular compounds. But later, in the beginning of the 19th century, there was a shift from this concept when there was an experiment done by this particular scientist. This is 1928. He did an experiment which resulted in the formation of urea. Urea, as we can know, is a compound that can be found in one of the byproducts from living organisms. So in that case, this particular experiment led to the formation of urea. By joining these particular ions, this is ammonium and this is ammonium cyanide. So it led to the formation of a compound which is known as urea. Of course, we shall give a formula representation for that, but for that case, it's just indicated as urea. So for this particular formation of urea from an experiment led to a mental shift from that idea that actually organic compounds can only be derived from living organisms. Now, in that case, then we can define organic chemistry as a subject that entails the study of compounds that contain carbon. So in simple terms, organic chemistry first is a study of compounds that contain carbon. So that's a general definition of the term organic chemistry, which is the study of compounds that contain carbon. Of course, we are going to look that there are some of the exceptions that defy this particular definition, because we're going to look at a range or a class of organic compounds and find out that some compounds, like this is carbon 2 and carbon 4 outside, are not regarded as organic compounds. And also this one can include diamond and graphite, which are compounds made up of carbon. Of course, or just elements made up of carbon, you will find that they appear in different forms and their properties are unique in a way that they are not classified as organic compounds, or for some historical reasons, they cannot be regarded as organic compounds. Another class of compounds, like this particular ion that we talked about, and even the carbonate, cannot be regarded as an organic compounds for historical reasons or some of the reasons that we shall discuss. Now, naturally, there are several elements, there are a number of elements that appear that we talked about as we were studying about an atom. But in our periodic table, in our modern periodic table, there are 92 elements and other artificial ones. Artificial, which means these elements can be able to be made maybe in the laboratory or through manipulation of some aspect of one element can lead to the formation of another element. So in the periodic table, that's a range of elements that we have. And as we talked about the electron dot notation for carbon, we also talked about covalent bonds, that when one element is forming a compound with another one, it either may result to an ionic compound or an ionic compound, or a compound that consists of ionic bonds, or the one that consists of covalent bonds. And we said that carbon in actual sense bonds with other elements or atoms to form a covalent bonded compound, which of course we are going to demonstrate shortly. Now, the ability of carbon to bond with other compounds leads to the formation of a number of compounds which are very diverse in nature. In actual sense, you'll find that some of the characteristics of carbon has led to formation of a number of compounds which are very important in our day-to-day life, hence necessitates the need for us to learn about organic chemistry. So what is the nature of this carbon that allows it to form a wide range of compounds? So we shall look at the nature of carbon. As we said that carbon is, organic chemistry is a study of compounds that contains carbon, except a few that we have mentioned. So the nature of carbon, it's good for us to know what is this particular nature of carbon. So first of all, we have said that carbon links with the other compounds to form what we call stable. I talked about electrons and the octet rule and the concept of stability. So they form stable covalent. We also learned about the concept of covalent bonds. So for that case, it would be easier for us to understand that. So for that case, it can form compounds or stable bonds with other elements such as hydrogen, fluorine, oxygen, nitrogen, sulfur, and phosphorus, etc. So you can see that carbon has the capability of bonding with a range of elements to form different compounds. So that one gives it its ability to have a wide range of compounds in nature. So carbon as well can form complex structures. For instance, long and branched chains, chiral, and even three-dimensional complex compounds. So this ability of carbon to form stable covalent bonds and also bond with the hydrogen, fluorine, chlorine, oxygen, nitrogen, sulfur, phosphorus, etc., gives it its ability to have a wide range of compounds that can be formed from this particular element that we call carbon in nature. So for that case, it can as well form complex compounds which are long chain, branched chains, gyro, and then three-dimensional complex compounds. Now this one gives us the ability to try to learn more about carbon and also try to see how we can be able to manipulate carbon to come up with the compounds that may be desired or of importance for us. Now for that case, due to its ability, you'll find that currently we have around 6 million non-compounds that are linked to carbon, or maybe organic compounds. These are organic, while there are around 600,000 inorganic. Inorganic means they do not display these properties of carbon or do not contain carbon in that case, to say. So for that case, it is important for us to know that if carbon forms this particular compound, of what importance is it to us, or how applicable is it to us, which makes us have a concentration or concentrate on studying its characteristics and nature. So quick, we shall have a look at the significance of studying these particular compounds, or the concept of organic chemistry. So organic chemistry is very important for us to study. So first, because through the study of organic chemistry, we know about the nature of biological molecules that play a very important role in our aspect of life. For instance, we can talk about the adenosine triphosphate, deoxyribonucleic acid, ribonucleic acid, which may be the last two involved in the formation of maybe genetic materials. So for that case, it's very important for us to learn this concept of organic chemistry, so that we are able to explain and learn in more details about the useful biological functions of those particular molecules. Now in that case, the formation of this wide range of compounds that we are talking about, many of them form part of our diet. For instance, carbohydrates, proteins, and even vitamins. Vitamins are part of the complexes that are formed due to that property of carbon to bond with other compounds to form complex organic compounds. Actually, in pharmaceuticals, you find that most of the medicines that we take in our hospitals, medicines, are the product of organic compounds. So for that case, it's good for us to study so that we can be able to come up with medicinal compounds or pharmaceutical products which are able to cater for our medicinal needs. And most of the fuels that we use to run automobile and industries actually is an organic compound, made up of organic compounds like the spirits or the gas that we use to run our vehicles. And maybe last but not least, you find that we apply different technologies to these particular compounds to ensure that we manufacture products which assist us in trying to build our environment, or maybe make it better, like the paints for aesthetics. And the plastics are made up of organic compounds. So these are some of the importances for us to understand the concept of organic chemistry. And as we are going to look further, we are going to see that it's essential for us to understand how we can be able to look at all the aspects of this and try to manipulate them for our benefits, and also trying to ensure that the life that we improve around us and our environment has been made better. So forward, we shall look at a representation of or maybe the properties that we can use to identify these organic compounds. So in this case, in our general procedures, maybe in the laboratory or somewhere, to look for the difference between, or to differentiate between a compound and a non-compound and the one that we know, we usually perform an experiment. And this one is some of the parameters that we can use to differentiate between a compound or a compound that we can refer to as an organic or inorganic. So in that case, chemistry has two main branches, that's organic and inorganic. In this sense, there's a need for us to differentiate between which compound is organic and which one is not. So for that case here, we shall list property or a parameter that we are going to use, and we shall have the two sets of compounds, that is organic and inorganic. So one of the parameters or the properties that we shall look, of course, is bonding. And we have said that organic compounds are formed by what we call covalent bonds, while inorganic compounds form what we call, we looked at the example of sodium chloride, which is an inorganic compound, so it formed an ionic bond. The second properties that we shall look at is molecular forces. Of course, when atoms bond with others, they form what we call molecules, and the molecules in that aspect also bond with one another. So the molecular forces, these are known as molecular forces of attraction. Of course, we shall learn about them during our topic of bonding. So these ones, they are generally weak, whereas in inorganic compounds, they are generally strong or quite strong. So physically, so the physical state of organic compounds, majority of the organic compounds are gases, liquids, or low melting point. Low melting point solids. And then for inorganic compounds, these are high melting point solids. High melting point solids. And then for flammability test, you'll find that most of the organic compounds are flammable, while the inorganic ones are non-flammable. Organic compounds are often, the solubility of organic compounds in water is often low, while that one is high. And then the conductivity in aqueous solution, organic compounds are non-conductors, while ionic compounds conduct. They dissociate into their particular ions which are able to carry charge, so which means they are able to conduct electricity. Now, the ability of carbon to form bonds with other carbons leads to the formation of what we call carbon chains. Remember, one of the properties or the properties of carbon that we said makes it very important for us to give it a concentration or to try to study about it, is that it can form long chain and chiral compounds, complex compounds, and even branched ones. So for that case, a carbon atom can be able to bond with another carbon atom to form what we call a chain, or a long chain, to form what we call a chain, of course, that we mentioned. So the carbon atoms can as well bond with different atoms that we mentioned, like hydrogen, oxygen, sulfur, etc. But for that case, we are going to see to look about an aspect of carbon bonding with another one, of course. Okay, let's say this, with another carbon, and we said that the valence electrons can be given a dot electron notation like this. So in this case, for them to form a covalent bond, you will find that they'll have to share the 2 electrons. So in that case, the 2 atoms will just be represented as such. This electron here and another one here. That will be the arrangement. And then we shall have 1, 2. So that will be the bonding of that particular carbon-carbon bond. They form a covalent bond. Now this bond can as well be represented as a dash. Of course, it will appear as such. So whenever 2 electrons come together to form a bond, a covalent bond in this particular case, we shall represent that particular bond in the form of a small hyphen, of course, which is being shown there. So this kind of bonding can go on and on. And then in some cases, you'll find that at a particular point, maybe we can have a compound of this nature, whereby we shall have a carbon, let's have this, a carbon bonded to another carbon at a particular point. Let's say maybe, for example, we started this carbon 1, 2, 3, 4. At carbon 3, we have a carbon atom that is bonded to that particular structure. So we shall have a name for that one. Now in this case, apart from carbon bonding with another carbon to form what we call the chains, these ones can be long chains or branched chains. So this ability of carbon to attach itself to another carbon at a particular point in the structure is what forms what we call a branched chain carbon. Now carbon also can display a particular property whereby this bond that we have seen here forms what we call a single bond between a carbon atom. There are cases whereby now a single bond represents 2 electrons. So in that case, we'll find that there is an instance whereby carbon, in its bonding ability, is able to bond with another carbon using what we refer to as a double bond. So this one is a double bond, which means it involves the use of 4 electrons, whereas this one is referred to as a single bond. It involves the use of 2 valence electrons which have been shared. These are 4 electrons. And in other cases, you can find that carbon has the ability to form what we call a triple bond. Which means each hyphen here represents 2 bonding electrons. which forms the third, of course, third aspect of bonding. So we have a single bond, carbon-carbon, double bond, carbon-carbon still but two bonds, carbon-carbon, triple bonds, of course, which are forms. We have specific names for these particular kinds of carbons, and we're going to look at this when we shall study about the functional groups. But for that, for the quick mention, these ones, when a carbon is bonded to a single carbon atom and its carbon molecules, and these are hydrogens, we refer to them as alkanes, alkenes, and alkynes. So we shall study about those when we shall talk about functional groups. Now there's a property of carbon that we are going to learn about, and this is very important insofar as formation of branched chain carbons or compounds is concerned, and this is what we refer to as isomerism. Now isomerism is the ability of carbon atom to link to more than two other carbon atoms, and it makes it possible for carbon to form two or more compounds that are same molecular formula but different structural formulas. So in this case, in isomerism, the same molecular formula but different structural formula, or just different structures. Now in that case, you'll find that compounds with identical molecules but different arrangements will result due to the formation of this, or the ability of this carbon to form what we call isomers. So the products that result from the process of isomerism are referred to as isomers. This is whereby the elements are connected in a different order, or maybe a compound is connected to the general compound in a very different order. We can look at two examples for this of what we are referring to as isomers. And one of the example is, this is a compound that is known as ethyl alcohol. These are hydrogen, because we shall study about the representation of this particular. Now for that case, you have already known that the hyphen here represents covalent bond, whereby the carbon is bonded to hydrogen, and it represents the concept of the valence electrons that we talked about. Now here you'll find that oxygen has been bonded to hydrogen and the carbon, but still those valence electrons which have not been bonded. Now this one is known as ethyl alcohol. Now ethyl alcohol has a compound that displays the same molecular formula, but of course it will have a different rearrangement. We shall have this particular compound here. So in that case, this compound goes by the name dimethyl ether. It's an ether. Of course, for that case as well, we shall look. You can see this one's, it's an alcohol. This is an ether. We shall look at different functional groups in that case, as I mentioned, to differentiate between these particular compounds. But in that case, you can see that both of them have two carbons, a single oxygen, and the number of hydrogens are the same, but the rearrangement of atoms is quite different. Now you'll see that when compounds display such a kind of properties, they'll have different physical properties, and even their characteristics, even chemical properties, will be they have very different chemical properties, and of some of the physical aspects that we are going to look at, like the one that we are looked at when we were differentiating between organic and inorganic compounds. Those particular parameters or aspects or properties are going to be different. For instance, for ethyl alcohol, you'll find that this is a colorless liquid, while that one is a colorless gas at maybe a particular temperature. Like this one, it's a colorless liquid that is at normal temperature, and their melting and boiling points are quite different. This one at negative 117, while that one at plus 139. This one is an intoxicant. While the methyl ether is used in refrigerator, so refrigerant. So in that case, you can see that already these are two different chemicals and their properties. When compounds display this aspect of isomerism, they also form different compounds. And this one gives the carbon the ability that we said that whenever it is displaying its properties, it leads to the formation of different compounds. So for that case, I think this one will give us just a slight introduction to organic chemistry. We're going to look at other aspects, of course, which we are going to discuss later in details. And for today, it was necessary for us to just have a recap of all the other aspects that were going to assist us, including the bonding, the history of this particular atomic properties, the notation of the bonding that we are shown of the dots, cross, and then maybe the circles for atoms. And then lastly, maybe trying to see some of the properties of organic compounds and how it developed over time. So next time we are going to look at functional groups and try to see maybe to some aspects how organic compounds can be named and what we call the organic nomenclature that applies some of the standard rules that we are going to mention. That is also going to give us a basis on how we can be able to name other compounds, be able to maybe try to perform some reactions in order to come with the other compounds in the organic chemistry, and also be able to link organic chemistry to other aspects or applications that we have mentioned, like development of pharmaceutical products during reaction mechanisms. Maybe we can look at reaction mechanisms at the far end of this particular topic. So for today, thank you very much. Welcome. Let's engage in the comment section. Bye. God bless you.